You might want to go grab some popcorn and some rum and coke because we're doing the electronics and this is gonna be a long video. Let's go! Welcome to part 4 of that Vz235 build, and in this one we're gonna do the electronics and we're gonna connect everything. I'm gonna show you how I've done it. I'm gonna walk you through the process and show you all the steps that I've done, and also we're gonna finish the printer completely. It's ready to go, it's ready to print. There's only tuning remaining, so on another video we're gonna do the firmware installation, main cell, clipper, all the rest of that, and I'm gonna show you how to do it. That's gonna be pretty simple, but this video is gonna be long enough like that without firmware installation, so we're just gonna focus on electronics. So I'm gonna show you my way. It might not be the best way, maybe you're not gonna like the way I've done it, but if you like it, feel free. I'm gonna put a link in the description on where you could get all the CAD files, the STL for building the back panel like I've done. So that's what we're gonna do in this video, electronics, and we're gonna focus on that. So without wasting any more of our time, let's jump right into it. And the first step that we will do is figuring out how we're gonna place every component on that backplate, because it's a small printer, even though it looks quite big, but it's a small printer and there's not a lot of room in the back. So we're gonna have to figure out a way to mount everything and make it look as good as possible. So let's jump right into it and let's do that. For the electronics, I think that's the layout I'm gonna go with. I'm not 100% sure, but I think that's what I'm going to do. So just to give you an idea, I'm going to use the Mellow Fly board with 4 of these kick-ass external drivers. 5160, what's cool about them is that they are external. They have these big, huge capacitors. It's version 1 and they're sold out. We're going to, well, Mellow's going to work on a second version better. I thought about the power supply. These are the 2 power supplies I'm going to use. This is a 24 volt power supply, the 400 watt power supply for 24 volts. It's a bit too much, but better more than not enough. And this is a 48 volts. This one is a 600 watt power supply, and clearly a bit overkill, but if you calculate that, if you run 2 amp on each motor at 48 volts, it's roughly 400 watts. So 100 watt per motor, believe it or not. So that's gonna be 400 watts just for motor, but that's gonna be peak. So 400 watt power supply, you should be technically okay for that. I just bought a 600 because I was not too sure if I would use one big 48 volts with a bulk converter to supply a 24 volt to the electronics. Oh well, I had another power supply in hand, so I thought I would use it. And I was not too sure how to place that because it's a small printer and as you can see it's a bit tight. I thought about doing the power supply and put them on there, but I would have to raise the printer about 1.5 inches, maybe more, to put the power supply under, and I didn't really want that. It's still a good option, but I think I prefer to use the power supply that way. So we're gonna mount them just directly on that back plate using the mounting screws, threads that are there. We're gonna do this, then we're gonna put a DIN rail at the bottom to hold all the electronics. So the Pi has already a DIN rail mount. We need to design something for that Mellow board for a DIN rail. We're gonna do this after that. I thought about doing a big mount for the Mellow board and all those 4 external drivers. So that's gonna be a CAD design we're gonna have to do. Then here we have DIN connectors, terminals. So we're gonna supply AC voltage here. We have our SSR relay for the bed, and here's going to be 48 volts ground and 24 volts, so DC AC. What else? We also have that CPAP. I think I'm going to put it right here, right next to the 24 power supply voltage. There's not a lot of room. It's either here or there. I prefer there because it's closer to this guy and there's not a lot of cable provided with that fan. So the control board, I will just print little enclosure, and I'm gonna mount it and just stick it on the side of the power supply or just right here. I'm not too sure yet. So that's gonna do it. But other than that, the CPAP will come out and go right here. I'm gonna punch a hole right here. I need another hole in the backplate for the intake. So that's gonna be next to do. And then screw that DIN rail and mount everything. So I think that's going to be okay. And then my plan is to have a backplate here that will cover all the electronics. It might be acrylic. I don't know yet. I still don't know how I'm going to do this, but I have time to think about it. I thought about using extrusion profiles here, another one here, and kind of another framing for this. Or I might actually just mount it here on the power supply and use the threaded holes and put the backplate right there. I honestly don't know yet. I'm not super going into very awesome looking back panel or backplate. I'll try to make it clean and make it look good, but I'm more of a make it work and then care about the look later type of guy. But yeah, we'll try to make it clean, and I'm gonna have to first design a mount for that Motherboard. Just a quick note on the Motherboard: if you're doing the all-wheel drive system, obviously you're gonna run 4 motors. The thing is, there's power for the drivers here from driver 0 to 2 and from 3 to 7. So if you plan on running your extruder and your Z motor on 24 volts and the 4 drivers at 48 volts, what you're gonna have to do is use this power bank for your external and provide 24 volt for 0 to 2. So the first 3 drivers here gonna be at 24 volt. And in fact, if you want to run the rest at 48 volts and use step stick, then you provide 48 volts to this guy. In my case, I'll be 24 volt, 24 volt, 24 volt everywhere, simply because I'm going to use these external drivers and they're going to have their own power input here, the VCC and the ground. So that's going to be 48 volts and you have your pair of coil there. So that's an interesting driver. It's capable of 6 amp, and look at those huge MOSFET. There are almost as big as the 5160. So they have also a cool external cooler, way bigger than your normal step stick. So that thing is huge. So it goes right here on top and will cover all the MOSFETs. And we're gonna have a fan on top of that. I need to design that, but crazy stuff, man. These could run a NEMA 23 without any sweat. And since they're not only 4 but 8 MOSFETs and big MOSFETs, you can run crazy power. So 100 watt per MOSFET is not a big deal for them. That's why I went with this setup. That's gonna be a crazy amount of power available for the motors. So, all right, let's just mount everything, punch holes where we need. I'm gonna stick them. I'm gonna use double-sided tape for the cable management. And then let's go onto the computer and design something for this guy and see if we can fit that. Are ready. Hey, so that's gonna be the mounting for the board, and this is gonna be the top cover that will go here, and we'll have our fans mounted, and we're gonna mount the drivers right here, 4, and And then this is the DIN rail adapter, and there you go. So let's see if that fits. We have our part. So the DIN rail is going to mount, the adapter will go in the back according to the CAD, like so. And we're going to screw on that later, but that should fit, hopefully. There you go. It's a little loose, so I'm gonna have to redesign them. I'm not happy. Way too loose. So put them on the side, not a big deal. Redesign that in CAD. Now let's see if all the things that we need to mount to this plate is gonna fit. It looks good. That goes right here. All the holes are aligning properly. Yes, I like it. Good, so that works. Now, let's see if we put them on the external drivers. One here, one here. And are we on the holes? Yes, everything looks perfect. Hey, that's good. First print, first design, everything fits perfectly. So that is good. And we're gonna have this guy that will just go on top like so. Yes, that fits good as well. And that will allow us to have 4 different fans with they're here, so we can mount them on top of that, and that's gonna keep our drivers very cool with those big huge heatsink. Haha, we're ready. So let's screw everything on and redesign those with tighter tolerances because I'm not happy with them. But other than that, everything looks fantastic. I could probably add another cover just to make it look better, but at this point I'm not into all the look in the back panel. But that looks good as is. I'll see later if we need to add something else to that design to make it look better, but I think I'm just gonna keep it because I have access to everything in there very easily. So let's just redesign those. Whoa, look at that. I forgot 2 holes in the CAD. Need to fix that. That looks good. Does it? I'm happy. Look at that. Pretty awesome. Looks like a massive electronics. I'm happy. This is good looking. Just need to correct those 2 screws in the CAD. Those 2 holes. I forgot about them. Not sure why. But yeah. Now we need to fix those DIN adapter. But yeah, so we're gonna have to undo the board. I just wanted to screw everything to just see if everything was fitting good, and it looks good, it fits good. So let's just redo them. Right, the drivers for Z and E, I'm going to use those Fly TMC 2209, and we're going to use port 0 and 1 for these two. So we can just install them. And for the 4 XY motors, the quad XY, these are the adapter for each of the slots, and they have all the pins that you need to connect to the external drivers. So we're going to use the last 4 slots. And if you are unsure of the direction of where to put them, here's the blue side and the black side, and same thing on the board, so you can't go wrong. There you go. And then we need to connect each of those with those little cables. I'm gonna have to remove this to be able to do this. Need more screws, and let's go now and do this. All right, I've just reinstalled the top with the fans just to have a quick look at how it's gonna look when everything's gonna be on, and this look like an absolute monster. It's awesome. Look at that power beast. Excellent. Let's mount it and do the rest. Mount everything on the printer. There's a lot of work ahead of us. There you go. Now it is mounted to the DIN rail. It's pretty solid. It won't move. I'm happy with that. And it looks epic. Ha. Okay, now there's a couple things that we need to do to this board. Well, the first thing first, these are the slots for the fuses, and the board comes with fuses in the box that we need to install. Very simple. There's only one that is lower fuse, and it's the 10th one, and it goes here. I don't know if you'll be able to see this. And they are tight. There you go. And the rest of the blue ones, they are 15 amps. They go here, here, and here. So I'm gonna do this. All right. Then we need to set all of these drivers, and these two is gonna be E or Z or Z or E. I'm not too sure yet. Whatever. So these are the 2209. So we're gonna have to set them with UART mode, and these are the 5160, and they need to be configured with SPI. They're gonna share the same bus, and according to the documentation, SPI mode and UART mode. So you can't go wrong, very easy. And the board comes with a bunch of little jumpers to use. So we're gonna use this and set this according. And then there are those fan ports here. And what's cool about it is that, well, first of all, they all have selectable voltage here with a jumper that you can see there. You can put your jumper either 5 volt, 12, or 24. And you also have to install a MOSFET in these slots here, and it comes with six MOSFET, sorry. And then very easy to do. There's no polarity. I think you can install them on every side. It's not a big deal. So just separate them like that and install them on the board. There you go. And you should have, oh, sorry camera, you should have one MOSFET left as a spare one. So keep that handy. That is the cool thing about this board. If you blow up a fan port, and all you have to do, remove the MOSFET, put in a new one. You don't have to screw up one port for that. So there's more ports that we're gonna need. So I just installed all of them, and then we can choose which one we're gonna use, but it's already on the wiring diagram on GitHub if you want to follow my configuration and use my firmware. So that's how I'm gonna use it. So let's just place those drivers in SPI mode and these in UART, and then we're gonna be ready to go. And then there is a cool port on the driver on the board for use with hold on. There is this guy here to connect the Raspberry Pi. There's also a Wi-Fi antenna that we're not going to use because we're not using wrap firmware. We're going to use Clipper. But the board comes also with this little guy. And that is the interface between your Raspberry Pi and the board. And you're going to connect it on the CAN bus port right here on the board. So it's very easy to do. So you don't need a power supply for your Raspberry Pi using this. And that's what is cool about that. So let me do this real quick, set the jumpers, and then we're ready to start doing some work on the backplate and mount everything. All right, jumpers are all installed, and I just want to point out a quick note about the Fly TMC 2209. In my case, I'm going to use them for the extruder and the Z, but if you were to use them for an X or Y axis and you want to run sensorless homing, you need that diag pin right here. And the cool thing about this board is if you don't want to use the sensorless homing and you want to use a standard stop switch, a physical stop switch, then you don't necessarily need to cut that pin off, the diag pin. You don't need to cut it because there is a little dip switch right here, and focus, maybe not. Yeah, and you can set that to off. Right now it's set to off, so I can use a stop switch for Z. So that's going to be the way you do it. I don't have to cut this driver pin, diag pin there. So in case I want to use this driver for something else in the future that will require diag pin, then yeah, just that little dip switch and you're good to go. All right, the first thing that we're going to mount on the backplate, the aluminum backplate, are my two power supply. And I really wanted to install them this way, like vertical. And I tried a couple of DIN rail mount options, and they were, I don't know, they were not solid enough. I didn't really like that. So I thought I would just simply mount them directly with screws on the backplate, and that way they are very solid. There's going to be a good ground connection to the entire printer that way. So I'll give you a very quick tip that a friend of mine gave me one day on how to use a scanner like that. If you have a home printer like this one, you can use this. You're going to scan the face that you want to mount because we want to find exactly the distance, and we're going to use the scanner as a drilling template to find exactly where the screw is going to hit on the back plate of the printer. So it's going to go to the left, so it's going to be mounted this way, or this way, sorry. Well, let's think about it. Do we want to protect and have the wires from the external of the printer, or I think I'm going to do it that way. Yeah, that way would be safer and better. So we're just going to place it on the scanner. We're going to scan it. And there you go, second one. And if you compare the two, you will see that they match perfectly good, and the holes should be very easy to punch or to drill. And we're going to use this to drill the backplate. So we are now looking at the inside of the printer. As the power supply will mount in the back like that, we have a photocopy of the back of this, and it matches exactly. So from this, it is very easy to drill holes. In this case, we're going to need 4. We're just going to use a punch, preloaded punch, to mark our holes. Done the holes, the drilling holes, and I've rimmed them with a bigger size drill to make sure, just to make sure the holes were not sharp. So normally, if we did our job correctly, it should align perfectly with the holes on the power supply on both sides, and it looks perfect. So we're just going to screw them on. There you go. Solid mounting of the power supplies. Power supplies are mounted, solid. Next thing we need to do is install that DIN rail in the middle, and we're gonna have to cut it to size. So let's do that next. Little bit of grinder again in the garage. I'll be right back. Good. The DIN rail has been cut to size, and I've just placed the electronics there just to figure out where I would need to mount it, but that was about in the middle of the power supply, and I want one screw on each side. I don't want to put a screw in the middle because that will land in the VzBoT logo in the middle. So I think one screw here and one screw there will be enough to hold that. So we're just gonna punch here, and we're ready to drill those 2 holes. Holes have been drilled here, and I have tapped those holes with M4 threads, so I'll be able to mount this with M4 because oh, sorry camera, I didn't use M4 nuts. I didn't want any nuts to be seen on the back plate from the front, so I tapped it. It's 3mm. It's enough to tap a M4, I think, at least. We're gonna see, but it is fine, I think. And since I didn't have any M4 that is like 3mm, I've used this ghetto mode, using a T-nuts to shorten that bolt. It's ghetto. I'll order some proper bolts, but for now that's gonna do it. And anyway, nobody will see that, nobody will know except you and I, which is a lot of people actually. Let's mount the DIN rails.
we got our DIN rails installed and all these little gizmos are installed, Pi is installed, so we're ready to do the next step. In my case, that would be installing the CPAP fan, and I want to put it here with the intake, the exhaust, or what's going to be pushing the air right in the middle, so that's going to look neat in the printer. So to do that, just want to make sure I place it at the right spot. So I'm going to use this extrusion to simulate where it's going to go. So I want to place this thing right here, just a little under. Now to do this, I'm going to use a special tool, and it's something very handy to have in your toolbox. This kit comes with a couple of size, but it is very easy to dig or to punch holes or to drill holes, sorry, with this kind of tool. So I will use this one. This is the one that I've been using to drill bigger holes in there. So first thing, one here, and we need another one here to place the CPAP right here. The only thing is I'm going to place the exhaust cover, the exhaust fan cover, just to make sure about where I need to put that fan. And I don't want to block also the top here, because we need 20 millimeter here in order to attach those frame brace. That's where the printer is going to be mounted to the wall, to that concrete wall. So it needs to be right about here, so it doesn't interfere with that fan and it doesn't interfere with anything else. So that's good. And we need one hole about here. So let's mount that too. There you go. And we're just gonna drill that. Who doesn't change his mind? I wanted to place the CPAP right here, but I found an issue with that. My goal was to put the CPAP right here, and since that control board is not very, they don't let you have long wire, I could redo those wires and you know, put longer ones, but I don't want to do this. My goal was to put the control board here on the power supply and just stick it there, but then it would block the access to the GPIO pins of the Raspberry Pi. And maybe I thought maybe mount it here, there's not enough room, that's going to be too tight. So I think the best place for me is to put it on the other side, like that, and have the control board mounted on the other power supply, like right here. So that's going to be better and will give me better room. Plus here is the port for the filament PTFE tube for that extruder. So yeah, I think I'll just do it here and that's it. I have marked the hole where I need to place, and I have marked the hole on this side as well. So we are ready to drill the hole, and hopefully that will work. So let's just do that. Of course, battery dead. Hold on. There we go. We're ready now.
How the hell you doing? I've been just fine living life with the newsstand in my mind. All I hear is music, watching your mouth move, getting look stupid. I feel like everyone's a stranger. Talk with your narcissistic neighbor. Real hard, but they take it off the table. Breathe what you did and I hate it.
I think that would be perfect.
You better get in line. Won't go another day of wasting any time. I've got a lot to say, can't hold it in this time. Got no filter, I got no filter. No filter, I got no filter.
Deburring tool. And now we can test it if it's gonna fit. Yes, this will be perfect like that. Now let's do this one. So that's gonna be the tube, where the tube's gonna go. Just gonna put a bit of oil. And same thing, but this one's gotta be shorter or smaller.
Sometimes I just wanna be a hater. Gotta watch down the top 40 with the chaser. The point starts feeling like a waiter. Switch it loud, loud and get the trainer. Before you go through, you have to sign a waiver. That's alright, I'm aware of the danger. You wanna get away, you better get in line. Won't go another day of wasting any time. I've got a lot to say, can't hold it in this time. Got no filter, I got no filter. No filter, I got no filter. No filter, I got no filter.
Taking a look, and that will do it. Perfect, good job. Now a bit of cleanup to remove that oil and we'll be good. Well, both our holes are done, and the CPAP, if you look at it this way, it fits perfectly in. So that is good. Now we need to drill 2 more holes so we can bolt it to that backplate, and then we go on to the next step. Well, we're gonna place it here. For the next part, we are going to install our cable management or wire management or wire rails or whatever you call that. And for this, we're just going to use double-sided tape. This tape is crazy strong and it's not going to go anywhere. And I think I prefer that over drilling more holes into that backplate. I'm trying to keep it as clean as possible. So that's going to do it. I've cleaned everything with isopropyl alcohol, so that way the tape will stick there very good. So in order to do this, I'm just gonna install the board back to place. Should be easy to install with the DIN rail. Then there you go, very strong fit. So I want to have a kind of a rail here, another one here, so I can move this guy just a bit like so. One rail there, one rail here, one here. 2 small rails here that's gonna connect like so, and here I'm gonna add small rails also, maybe at angle, I don't know yet, I'll just see. So let's start installing that. All right, that's it, I'm done for tonight. It's past midnight and I'm tired, so I'm gonna stop here, but I've done all I wanted to do today or tonight. The cable management is all done, everything is good. I like the way it looks. Looks clean. This is the CPAP setup, that is where it's gonna go. I have enough room here for passing the wires, so overall I'm pretty happy with how that looks. It's gonna be clean, could be cleaner, could be better, but for me that is not something I'm really comfortable with doing. This is the worst part of the build for me, doing all the wires, but I think I like this setup. So that's gonna be it for tonight. Next thing, we start all the wires, and that is going to be a long part, but it's going to be a fun one. So anyway, let's just go to bed and resume that tomorrow. I had a good night and I've recharged all my batteries, so I'm ready to mount this backplate to the printer and attack the wiring. I've also printed my backplate for that CPAP controller board. It is now mounted to the back of that power supply, ready to go, its final location. So we are ready to mount that backplate to that printer. And I've also installed my hot end, as you can see here. Wire has been passed as well. It just needs to be cut and fit a connector. I'm going to use a micro fit connector. So that is next. But first, let's mount that backplate to the printer. It's ready to be installed. There you go. The panel has been mounted. Everything is solid. So this is what it looked like from the back. And I just realized I created myself an issue that I'm gonna have to fix. And this is about that CPAP. So if we look, so everything is really tight in the back of the printer here. So my goal was to use this guy here, and I've made a hole there for that. The issue with that is right here. If I want to go all the way back, it's gonna touch the belt. It's gonna create issues. So I thought maybe I would have been better if I made a hole here instead, like right there. But it wouldn't be looking as good, I think. I have OCDs with symmetry. Maybe I could have put here, but then I would have need a longer hose between the fan and here. That would have been good, but that would mean a tube plus a umbilical cord. So I do have another options. So this is a mistake, not a mistake. This is something I didn't think about. So I'm gonna have to find a way to make everything fit. So my idea is to use something between the belt and that 2020 extrusion. And I think I've measured that there is like 12 point or maybe 13 millimeter of space. So if I could design something that would fit right there and go all the way in that hole and go on the other side, then that would be good. So that way I could probably mount this right here and it wouldn't be in the way of everything. And if it's that way, then it means that it's gonna be good. So yeah, I like that idea. So let's go on the computer and fix that that issue that I created myself. But I think we're gonna be able to design and do something good. Boom! Hey, there you go. I've created a stupid issue. I have fixed that, and I'm really happy with that solution. Let me show you. So when it comes all the way to the front, that's how it's gonna look. So there's enough tubing there, and the tubing in the back, you can just unplug it there, and that thing's gonna act as the cable holder for all the cable management. So we're gonna tie wrap everything together with that too. So that's gonna look clean and good. And that part was printed in 3 parts. The belts are in front, but yeah, you can see, let me maybe lower that camera here. Yeah, printed in 3 parts. So that middle ring here is a part, this is a part, and then there's a top part for the tubing, and that is how it's gonna hold. And if you can see that there is enough clearance between the belt and that part, so this is awesome. I happy with that. Let me show you in the back. In the back, we have this guy that comes out, and the hole is completely filled with that ring. We can just put it back. We can put it a tie wrap, but just like that, it's holding hard enough. But we're gonna put a tie wrap anyway. So yeah, that's a cool solution. Let's plug that back in. And if I bring the print head all the way back, you can see this is about the maximum position to hit the print area, and we have full clearance in the back. We can go even all the way if we touch in the back, and it's touching, but it's fine. It's not going to cause issue, but we don't have to go that far, so that's fine. The maximum we'll go is about here, and that CPAP tube will just lay down on its side like that, and about like that with all the wirings. So that is good enough for me. I'm happy with that solution. So on to the wiring. Let's do that. Let's attack this wiring. So to start with that, we're gonna need a bunch of things, and we're gonna start with this is gonna be sleeve for wires, nylon. We got a bunch of pre-made connectors, microfit connectors. We got another bunch of pre-made 2 and 3 and 4 prongs connector, DuPont connectors. We're not gonna use this. Well, maybe for the Pi and the CPAP. Fuses, what do we have? We have used that. Those are DIN connectors. We have our heat shrinks, more heat shrinks. What else? We have 12 gauge silicone wires, way too big. 12 gauge again, 12 gauge again. We have 24 gauge, 22 gauge. We have these hot melting connections. It's like soldering, but without actually soldering, just with heat. It's gonna solder. Another pack here. We have a bunch of microfit connectors, microfit 3 connectors, female, male. These are 2 prongs or 2 socket connectors. I also have some pre-made. I'm not gonna use that. I prefer to make my own. So we have this. We also have some braided sleeve. We have some more sleeves for wires. I already have a couple of pre-made cables, probably gonna use for power supplies. We'll see. What else we have? I have this bag of it's full of different wires that I've accumulated with years. Lots of useful stuff. This is a bag that I keep. What else do we have? We have lots of fans here. We have thermistor PT100, NTC thermistors. I'm not too sure which one I'm gonna use. What else we have? We have a couple stuff, way too much stuff. This is our bolts and sprigs. So okay. Oh, we have lots of tie wraps, Velcro tie wraps. So that's gonna be useful. What else? So I've prepared all my tools. Here we got ferrules connectors. With the crimper, we have another kind of crimper that I like to use for microfit or any kind of really, it's good for JST, it's good for DuPont. That one is my favorite crimper. I have another crimper for DuPont connectors. It also works with a lot of other stuff like JST. So we have our DuPont's connectors. The Motherboard comes with all you need to wire up everything. So you have your JST connectors, you have your JST female, male pins, and they give you also a couple of terminals. But I do have my own terminals. I have other terminals. I have this terminal crimper. I have this
wire stripper, another kind of wire stripper, and these are very handy. It's a kit for removing pins, different connector pins. I think I have all of them. Very handy when you do kind of a connector and you want to remove the pins. This is what I use. And what else? I think that's about all we're gonna need. Yeah, I have way other stuff. Oh, my soldering station is ready in the corner as well, so that is good to go. We're gonna start by doing the AC connection. So we're gonna go from the power from the wall and gonna bring that to the DIN connections here. So that's gonna be like the ground's gonna be there, and then neutral and the line, and we need to feed both power supplies as well as the SSR relay for the bed, and that's about it for AC. So we're just gonna start by AC. And we have a heat gun, so that's gonna be useful for our heat shrinks. And we have, not this one, right here, we have a labeler, what I call a P-touch. So we're gonna be able to identify all the cables, all the wires, so that's gonna be clean, and that's gonna be useful later on if we need to work on the printer. So we're good to go. Oh, one last tool that you will probably need, and if you don't have a multimeter, go ahead and buy one. This is absolutely necessary in every project you're gonna find or you're gonna do. If there's any electronics or wiring to be done, this is very useful. There's connectivity or conductivity. Yeah, that's the word. So you need a good multimeter. All right, we are done doing the AC connections. Very, very simple step. So let's take a look at what we need to do. Let me zoom in here. So we have the line, the power line from the wall. That's gonna go here. It's gonna bring line, ground, and neutral. And then it's gonna feed this DIN rail adapter or connectors. And then from these, I am feeding the AC power to both power supply, the 24 volt and the 48 volt. So we have 3 wires now, sorry, on each power supply, ground, line, and neutral. And then we have another connection from the line that goes to that SSR relay. By the way, I need to change this. This is a wrong SSR relay. It's activated by AC and not DC, so I ordered it wrong. It's on order. I will replace that tomorrow. So we have the line that will feed the relay, the SSR relay, and then the line will come here and go to the bed. And then we have a neutral wire as well, the white here, that goes to the bed. And this is the bed wire. So the bed comes here and it's grounded to the frame, as you can see with this connection here. But it could as well be connected to this because the way that these power supplies are, the ground from the wall is already grounded to the frame of that power supply, and the power supply is directly connected to the back of the printer on the aluminum plate. So everything is grounded now, including the bed, because the bed uses this connection to here. So I've also applied stickers just to make it clean and see what goes where. So we're going to connect the 48 volts power supply here, and then the DC negative here, and 24 volt here. So that's going to give me a possibility to go feed 24 volt to that CPAP control board. But if I need something close like these connectors here for 24 volts, that's going to be good. Or I can also use the connectors that are here on the board. But like that, that's going to be good. So we're going to feed those drivers directly from these guys. So we're done with the AC. Let me show you maybe the bed, how I've done the bed. Yeah, that's a good angle. So this is the bed plate in the back, and that bed plate has 2 holes. You'll see them here, 2 holes, and they're M2.5, I believe, if I remember correctly. And one is used to ground the bed plate directly, so here's the ground wire. The other one is used to install, and let me zoom in, a
thermal fuse, would you focus please? Anyway, you see that thermal fuse right there, and that thermal fuse should be connected in line directly with the line from the AC power. So this is the line that's coming out of this relay. So it goes all the way to the bed, and the other wire is the neutral. So it's very important that that thermal fuse is connected to the line. This is the line that you want to cut in case it goes bad. So that's about it for the bed. The bed is ready. So now we are ready to do the rest, which is connect the power supply to this, and then we can start wiring the rest. The red wire that you see here is the bed thermistor. So we're gonna have to hook it up as well and connect the rest. So we're just gonna do one thing at a time. Let's connect this guy to here, and we're gonna connect all the ground from the both power supply together as well. Yes, it is Friday night, and this is a good day because, well, it might be a sad day because I'm almost out of rum. I'm running out of rum, but yeah, haha, all the DC connections are done. So let's take a look at it real quick. We fed 48 volts directly to each individual drivers here. So they all have 48 volts. We have fed 24 volts to that CPAP controller board. We have fed this guy here, the motherboard, the 3D printer board. So from left to right, this is gonna be power to feed the SSR relay that I've changed for a normal DC one. That's the good model now. So bed out, bed in, 24 volts. It doesn't need to be big wires, though I've used 16 gauge everywhere. Since we're not feeding the bed directly, we're using SSR at AC. It still needs a DC 24 volt to operate and to activate that MOSFET. So this is gonna be main board power supply, 24 volts. This is gonna be your driver 0 to 2. So this one, and this one, those three. And before revision 1, they were called high power because those were the only three that could be supplied 48 volts. Now with that revision of that board, the 1.2, you can wire 48 volts to all of them. So this can be high power as well. So 0 to 2, 3 to 7. One thing to note, since we're doing all-wheel drive, we need 4 at 48 volts. So we can't use this guy at 48 volt. We need this guy because it has driver from 3 to 7. So we need those. So 24 volts for E and Z, or Z and E. I don't know yet which one I'm going to set up. So that is done for that part. What else? Yeah, I've taken the opportunity to wire, to label every wire. So every wires on the DC side is labeled. Same thing on the AC side. That way, when I work on the printer later, it's going to be easy and enjoyable. I won't have to trace and chase any wires. It's going to be right there. Next step, wire every components on the board. The thermistors, the stop switches, what else? The hot end, the motor connections, all the drivers connections to motors. And the Pi needs that CAN bus port right here. It's going to feed the power as well to that Pi. And then a USB cable, obviously. And what else? I think that's going to be it. Well, we need also one wire here to control the PID, not PID, but a PWM signal from the Pi. That's how I use my CPAP. So let me switch to wide angle so we can see a better view of that thing. So we're done. So next step, wire up all the components. That's going to be a long part as well. But we have, well, no, not anymore. I'm running out of rum. I might have to switch to beers now. We have wired one of the motor. So just want to show you how we're going to use those. And I have crimped connectors to it, or what's called ferrules, because we're going to hook them up to the 5160. And what you need to do, because we have 2 pairs of coils, and you need to find those coils using your multimeter. When there's signal, it means you found the pair of coils. So very easy. Normally it should be green and black, depending on the cable. There's no really standard for that, but most of the time they are. So there you go. We have found coil 1, and that should be coil 2, or 1 or 2, vice versa. So that way we can hook them up here, and it's gonna be easy. Let's do that for all 4, and we are ready for the next step.
What a waste of time. I was not happy with how those wire rails were looking in gray, so I had to do something, and I had some leftover vinyl or vinyl, whatever you call that, the wrap, carbon fiber wrap. I don't know if you can see this, but now it looks much better, at least to my opinion or to my taste. So now let's go on and stop wasting our time and do the rest of the wiring. We're so close to make that thing work, so let's go. Progress, we like progress. I like progress. We're done doing all the X and Y motors. They all hooked up right now, so each pair of coils have been connected to motors. That is good to go. The connection goes down here, and either on this side or on this side. And then we have also hooked up the wire for Z and the extruder. So Z goes directly, boom, right there. There's an opening right for the Z motor. And then the E goes, if you follow that wire, it goes into the umbilical, whatever, that thing that goes to the print head. We have also wired the bed thermistor. We have also wired, this is the output to bed. It goes right here to that SSR relay. We have also wired the, that is the hot end fan, if we ever use a hot end fan. That might be water cool fan if I go water cool. We've wired, this is driver fan, so it's connected to all these 4 fans, so it's gonna fire up when the driver is gonna fire up. And we have also connected the hot end thermistor. We have connected the Y stop switch, the X stop switch, and the Z stop switch. And all the wires are coming down this way from either side to reach whatever inside the printer. So except probably, nah, I think that's it. They go all the way there. So let me show you the stop switches. So you have your X stop switches right there on the print head. It's going to be this guy here. It's going to be activated when it moves there. You have your Y stop switch right here. Click, click, click. And it's going to be activated by the MGM sliders. And then in the back, you have your Z that is right here. And it's coming all the way down here. So that is it for stop switches. So that part is done. I've also done the entire print head wiring. So that thing is ready. Let me go under the light for better seeing of what's going on. So we have here the extruder motor. We have the stop switch, the yellow and black. We have the white wire is the thermistor on the hot end. We also have, might be hard to see from here, but the hot end connection. And we also have an extra wire. This is going to be the fan if I ever need a fan, because right now I think I'll be okay with just heat dissipating into the whole print head. I don't know, and there might be water cool, so I just hooked up that wire in case I need it. What else? Let me show you something. Moving the printer out of the way, so let me switch back to wide angle. I found a little issue with my setup here, and the issue here, when I want to wire the power for the Pi, which is right here,
So when this guy is in front, I didn't think about it, but I won't be able to connect that power supply. So I'm gonna have to use, this is the CAN port, there's a 5-volt and a ground. So I'm just gonna hook it up the power through the GPIO. So issue is resolved. Then we have our USB cable to control the board. And this is a USB camera. It's an Arduino cam I'm gonna use instead of using a Raspberry Pi, because it's just easier. The USB cable, it came with the USB cable, everything was built in, so I'm not gonna have to run the CSI cable through an HDMI and whatever. So it's an 8 megapixel Sony sensor. I can show you that later, but yeah, that's done. So what else? Yeah, we have another thing that I'd like to show you. I wanted to kind of have a backplate that will cover everything, all the electronics, and be safer so I'm not gonna touch the wires. If I pull the printer from the front, I'm not gonna be able to touch. This is protected already. There's a plastic cover on it, so that's safe. That is somewhat safe, but I didn't like it. So what I've done, I've designed this guy here. So this guy is gonna be here. What side? This side, like so. So it's gonna be right here. And on the other side as well, we have this guy. So it's gonna be here, like that. And if you look on the side, that's gonna be closing the back of the printer. And then there's gonna be an acrylic panel right in front. So that was super simple. I just thought I would use the power supply as like mounting for the panel. I wanted to have a metal frame with extrusions, but said, wait a second. We have these that could be structural and hold. They have M4 right here. So I just put the plate there, and that's it. That's gonna be an easy backplate. And I'm gonna put this somewhere on the backplate, Vz235, and maybe a carbon fiber logo or something laser done by my brother. So let's just finish that printer. It's almost ready to fire up. Next step will be the RSCS fan on both sides. I need to do them, and the exhaust fan. But this is really easy, and I don't need them to start the printer and start testing and play with the firmware. So I think that's not gonna be in this video. Maybe if I have more time, I'll see. Whatever. Let's just finish this. I'd like to install that just to see how it looks. Boom! Hey, the back panel is installed, and I'm happy with the result. It's a good backplate. So it's like, yeah, everything is open, so heat can come all the way up, and it's protected in the back, so nobody can come and touch the wires by mistake. So I'm not too sure if I'm gonna keep the acrylic panel, but for now it looks good. I might do a carbon fiber plate or an aluminum plate. I don't know yet. Quick detach everywhere, so easy to remove. So I'm happy with that. I've also installed the exhaust filter. I still need to do the wire, so it's gonna go to one of the fan port. It is filled up with carbon activated filter and a 3M hammock filter, which is right here. That 3M filter, this is this kind of cut to size filter, and this is the carbon activated filter. Okay, yeah, this is gonna be the camera. It's a USB port going all the way to the front because we're gonna put the camera there, and the camera is this guy here. It is a Arduino cam with a Sony sensor. Yeah, you can see that Sony sensor. It's a very good sensor, actually, 8 megapixel. I decided to use this camera instead of the Raspberry Pi simply because it's a lot easier than the CSI cable from the Pi that is always catching noise when you run 48 volts. So USB, it's shielded already, so that's good to go. And if I would have run the Raspberry Pi, I would have needed a converter from CSI to HDMI, which add to the cost. So this is about the same sensor as the Raspberry Pi version 2. So I'll run that one, and it's ready to be mounted in the front. I've also installed that LED light. I need to wire it up. I'm not gonna do the RSCS fan on both sides simply because I want to test the printer first. If there is anything that needs to be worked on, I still have access, no panels, everything is open, so that is this is good. Yeah, I think that part is printed and done. Let's open up that Vz235. Oh, and it came out great. So this is gonna be the mount for that little guy here, and it fits good. Holes are aligning. Yep, that's very good. And you see it's at an angle like that. And it's gonna go in the front. Maybe I can show you that. It's gonna go here at the top, and there is quite an angle to it because the bed is a lot lower than the Vz235 because the Vz235 has an extrusion that comes right here. So I'm not too sure if that's going to be the final setup. I'll have to see how wide angle that camera is, and if it's not good enough, I'll put it here somewhere in the corner. I'll do another kind of mount that will go there. So we'll see later, but for now I'm going to put it there and see what it does. And we are ready to test, guys. I think we can fire up the power very soon. I'll do the rest of the wiring. And yes, fire it up. And hopefully nothing's gonna blow because I'm very nervous on the first startup. So let's just do the rest of the wires and fire this printer on. I was about to say bad words, sorry. Okay, I've added the last remaining little pieces to the puzzle, and this is, I've connected power to the Raspberry Pi. It goes all the way, let me switch to wide angle. Wide angle, okay, from Pi, it goes all the way to this guy here, the CAN port, which provides 5 volts and ground to our Raspberry Pi. And then I have connected that GPIO pin, I think it's GPIO pin 26, and the blue wire is for the CPAP connector, which goes all the way into this guy here. Focus good. Okay, so CPAP is connected. I've also connected the, where is it? The LED. It is right here. LED is connected. And then we also connected, what else? The camera. Camera is connected and ready to film. So that is good, everything is there. And I've also added the chamber temperature sensor, which is, where is it? Right here, CT, chamber temperature. And temperature goes all the way here, and if you look inside the printer, the wire will come all the way up, and this is our temperature sensor. So it's gonna catch all the temperature inside the enclosure and report to us. So we are close to being able to fire it up. One last thing, I'm having a hard time with just one hand. The last part, the last piece is this guy. Papa, that Pi screen, it's a Big Tree Tech Pi 5. This is version, I can't remember. 1.2, is it written somewhere? Whatever, it's the latest version. So it's ready to be installed in the front. And for that, we're gonna need a CSI cable. This one is 1 meter brand new. We're gonna hook it up to that CSI port. I just realized I'm gonna have to remove that pi and connect that. So I'm gonna do this now. I don't think I need to film this, but look at that. Look at that. I'm really happy. It's almost done. Let me connect that screen and we fire this guy up. LCD connected. There you go. That CSI cable. I'm not just too sure if this guy here will catch some noise from the AC lines. I don't know. We'll have to see. But it is ready. Screen is installed and is ready. So let me hook up the power and pray that we don't burn anything. Haha. Okay, we are ready to turn on the power, but just before we do this, I just want to point out something. I had this guy connected wrong, and I've realized it when I've put the sticker, because that board comes with a sticker that you can put here, and you have your bed out, and you notice this guy here is inverted. So you have 2 plus 24 volt right there. So this one had to be reverted. Other than that, we are ready to go. So I'm just gonna back up a bit because I've seen a couple capacitors exploding in my life, and I don't want to do this again. So I think that's gonna be fine, but we'll do this right now. Ready? 1, 2, 3. Oh, that can't be good. I'm gonna close it. Okay, that means we have a problem. That board has an alarm. It has a little speaker right here that will warn you if you have something shorted or something wrongly connected. And I'm gonna take a look at it and come back to you. I found my mistake. Very simple and very stupid at the same time. Let me show you that. Let me quit zoom the wide angle. And here are my stop switches, the connection, and I have stupidly connected them the wrong way. So I have shorted the plus and the ground together, which is very good. So I need to just redo them. I need to go to the top and the middle. So the signal is in the middle, and no, signal is stop, ground, and then plus. So let me redo them. But the good thing is that board has a built-in protection for stupid guy like me. So if you short that board, it's gonna be protected and will warn you with that little speaker. So that is a very good option. Okay, I have rewired, I've changed the pin connection here, so we have the signal, the ground, and I'm not gonna use the 5 volt, and I'm not gonna create any shorts. So we are ready to power up again. So let's do this. 3, 2, 1. Much better. No beeping sound. Both power supply are powered up. We see the LED on each power supply. That's good. We see the LEDs on all 5160. That's good. We see LEDs on the board. Here we have power, the bed, power to drive 02, power to drive 37. That's good. I think everything is working. The Pi also has, is the Pi? Yeah, the Pi is flashing. So we are good to go, I think. The CPAP is also powered up. So next step is to install the firmware on the board, and then on the Raspberry Pi do the main cell and clipper stuff. So that's next. But just before we jump into this, let's put back the rail on the wire management and the back panel and see how that looks like with everything on. Here we go, back panel is installed and mounted. We've also covered all the wires with the carbon fiber wrap that I've done, so it looks good. I'm really happy.
that is just a sexy back, and it's protected, so that's all I wanted for this one. And it's easy to remove, so everything will be very fun to work on that printer. So let's just take a look at what it looks when we look at the side. That's it, and yeah, that's very good. I'm happy with that. All right, and there you go. I've taken the time to install the enclosure panels as well as the RCS. I really wanted to complete all the electronic wires and everything, wire everything, so everything is ready to do this, the firmware stuff. So it is ready. It looks very, very good. I'm really happy. Let me just rotate that so the light is good. So we have the doors. That's good. Everything's good. The top panel is also installed, and it's quickly removable. It holds by magnets on each side, so that is also a good thing. Yeah, again, RSCS on both sides has been installed. So we are done mostly on the printer. The last remaining little bits are gonna be from the back. I need to print caps to cover those two holes on both sides and keep the opening, because we need to do sometimes the maintenance, remove motors and everything, so those holes are there for that. So just to recap on the motors, and that's going to be also in the documentation, but again, we have drive 4, 5, 6, and 7, so that's going to be X, Y, X1, Y1, and if you look at the printer, the motors in the front are X, Y, and then Y1, X1. You need to pair them in diagonal. So this one works in parallel with this one. Not in parallel, but I mean they work together on the X, and this one works with the rear left one. So Y and X. And that is how you connect them, and each have their own drivers so they can fully power 2 amps on each motor and be extremely powerful. So that is it for now. So I think I'm done, and the next step will be firmware. So I'm gonna have to do that, and then I'll show you how I do it. So it's gonna be very simple. I'll have a configured config file for all of you guys that wants to do the setup as this one, so that's going to be easier for everyone. So I'm going to work on that next. Yep. Oh yeah, I'm happy. Look at my face. It's the smile of a happy man that is done doing all the electronics, and for me that was quite an experience, because I'm really not the best in the electronic part of that build. So it's probably the hardest part of the entire build process, but not that it's hard, it's just more time consuming. You really got to be careful not to make an error and plug something wrong and burn the house down. So just be extremely careful, and if you spotted something in that video that I've done completely stupid or that is not safe and that needs to be mentioned, please comment down below. I'll be really, really happy to be corrected. And just don't do it only for me, do it for the entire community that is watching those videos, because if there was something unsafe, we all need to know, and I'll be really happy to be corrected on this one. So that was it. I've given you my way of doing it. Of course, it's a DIY printer, so there are many ways you could do it. You could mount the electronics on there, you could mount it on the side, you could, I mean, do it the way you like it. If you like the way I've done it, then I'm gonna share all the CAD files with you with the little walls, I don't know how to call that, on the side, the knobs, the motherboard, DIN mount, and well, everything you see on this one. I'm gonna share that with you so you can reproduce if you like the way I've done it. If you don't like it, then do it the way that you'll be happy with. So we're done. I mean, next step's gonna be firmware installation, clipper, main cell, clipper screen, and a bit of tuning, and we're gonna try to start testing the limit of that motion system, because I'm really excited about this one. I just yeah, that's gonna be very interesting. So if you don't want to miss that one, if you've not subscribed yet, please do it. If you don't want to miss it, ring that bell in the corner. And if you like that video, please hit that thumbs up. That's just helping me, and I'm really thankful when you guys do it. So don't miss that next one. So for now, I think we're done, and I need to go to bed because I'm exhausted. But that was very fun to do, and I hope that you guys can have the same amount of fun doing it. And don't forget, in that entire project, you need to stay hydrated. So don't forget your beer, wine, rum, whatever that makes you feel happy. Water, if it's water, that's totally fine. But just take your time, enjoy the build process. It's a fun build. I'm telling you, I had a lot of fun doing it. It's not done yet, so we're just there. Still a couple parts missing here and there, but mostly done. And now it's just time to enjoy what we've done, enjoy the hard work that we've put in, and start printing and see how that goes. So on this, folks, thank you again for watching. I really appreciate it. I really appreciate it, or I appreciate it and appreciated it. So I'm gonna see you on the next one. So on this, have a good night and see you later. Bye-bye.